In this video, I'll be explaining the very basics of finite automata. So to begin with, what is finite automata? It is the simplest machine that is basically used to recognize patterns. Finite automata consists of a finite set of states, and it also has rules for transitions from one state to the other based on the applied input symbol. If the input string consists of a pattern that is identified or rather defined by the finite automata, then it is accepted, otherwise it is rejected. The following diagram gives an example of how a finite automata looks like. So in this diagram, the finite automata has two states, A and B. The starting state for the finite automata is A, and state B is the final state. As is seen from the diagram, when the finite automata is in state A and it receives an input 1, then the state remains the same. However, if it receives an input of 0, then the state of the finite automata changes from A to B. Similarly, when the finite automata is in state B and it receives an input of 0, then the state remains the same. However, if it receives an input of 1, then the state changes from B to A. Next, what we are going to do is, we will basically take two input strings and we will be checking if that particular input string is accepted by the given finite automata or not. So the first input string that we have is 100. So as we discussed earlier, the starting state of the finite automata is state A. Now as we parse the input string from left to right, the first input character that we have is 1. So currently we are in state A and we receive an input of 1. So from the given diagram we can see that the state will remain the same. The next input character that we have is 0. And the current state of the finite automata is state A. Therefore, on receiving an input of 0, the state will change from A to B. The last input character that we have is again 0 and the current state of the finite automata is B. And like we discussed earlier, when the finite automata is in state B and the input is 0, the state remains the same. Now since the state B is the final state in the finite automata, therefore, this given input string 100 is accepted. The next example that we have is the string 101. In a similar fashion, we will again start parsing the string from left to right. The starting state is A, it receives an input of 1, the state remains the same. Then it receives an input of 0 and the state changes from A to B. The last input that the finite automata receives is 1 again, and the state is currently B. And as we can see from the diagram, when the finite automata is in state B and it receives an input of 1, the state changes from B to A. However, the state A is not the final state of the finite automata, which is why the given input string 101 is rejected. Next, we will basically discuss how we can represent the finite automata. Finite automata can be represented by 5 variables, and so basically we can say that the finite automata is a collection of 5 tuples. So the first variable that we have is capital Q. Q defines the finite number of steps, finite number of states that is present in the finite automata, and for our given example, Q consists of two states, A and B. Next we have sigma. Sigma defines all the input symbols that are allowed for a particular finite automata, and for our given example, sigma consists of values 0 and 1. Next we have small q0. In some places it is also represented by small q. So q0 defines the initial or the starting state for the finite automata, and for the given example this is state A. Capital F defines the final state, and for our example it's state B. Lastly, we have theta, and this variable tells us all the possible transitions that are allowed for a particular finite automata. It can be represented in a tabular format, and this basically consists of two inputs, which is basically the input state and the input symbol, and the output tells us to which particular state the finite automata will go to when the input is given to the given input state. So that's all. Thank you so much.